You may already know a lot about it, but MicroPython, as the name suggests, is a lightweight version of Python designed for embedded modes where resources are not as abundant as on a typical desktop PC. In such cases, code is usually written in C or similar languages, but MicroPython allows Python to run in these environments. This enables you to control hardware using Python. As I mentioned earlier, we will be using CircuitPython. You can think of CircuitPython as being similar to MicroPython, with the key difference being that it has been optimized by the company, Adafruit, to make it easier for users to work with. You can consider CircuitPython as just another version of MicroPython. We will be using CircuitPython to control hardware, specifically using a kit based on the NRF52840 from EO1 Studio, which is sold by DeviceMart. You can see the NRF52840 label here, but for reference, I have made many products using the NRF52832. So if you have any Bluetooth related devices, you might come across those made with Nordic's NRF3 or NRF52840. So this is a development kit that uses the most commonly used Bluetooth chip, and here you can control things like LN using Python. This time we will use the NRF52840, but later, when the opportunity arises, I will also explain how to control using MicroPython and CircuitPython with ESP32, which is Wi-Fi based, and STM32 based devices. Looking briefly at this kit, it is possible to control LEDs with eAWT Python, or control BLE since it has Bluetooth capabilities. Additionally, if you look closely, there is a module part for GPIO, specifically the MCU module. In the case of the NRF, we use J-Link as the programmer, which can be connected to download the programmer, or we can update the Python code using the USB port. The USB can be used, and like other MCUs, GPIOs are arranged here, and controlling SPI or I2C is the same. Additionally, in this comprehensive kit, you will find that there are expansion boards and various components, specifically including such as the J-Link programmer, which is a common tool for programming and debugging various microcontrollers and devices through a USB connection or interface. It is currently bundled into 3 main packages for your convenience and ease of use. So in this session, we will conduct a lecture based on the Bundle 3 standard package, and for this time, you only need this module. Let me just briefly take a little look at what the contents are. As you can see, there is quite a lot of content here. This is the NRF52842 module, which acts as the brain running the actual Python code. It has built-in NeoPixels, as well as buttons and LEDs. For this session, you only need this module. However, in the future, you can connect it to an expansion board. By doing so, we will control peripherals, sensors, and actuators using the expansion board. Additionally, we will provide a little bit more detailed information about the module and its capabilities in this session, as well as future possibilities with the expansion board. Looking at the contents, it includes components like submotor, relay, light sensor, ultrasonic sensor, RSense, and Neo set strip. I will explain how to connect and control these in the next session. Here, on the CircuitPython page, if you look at the download section and search for the keyword NRF928400, for example, you will find CircuitPython compatible boards for the NRF52840, such as those that you can easily find. The board we are currently using is exactly the same as the NRF52840 compatible board listed here. Following this, you have the option to download the firmware for CircuitPython that is specifically designed to run on the NRF52840. Normally, when you purchase the EO1 Studio NRF52840 kit, the CircuitPython environment is already conveniently set up, but it is still better to use the latest version of CircuitPython in order to ensure optimal performance. So, please set the language to US on this site and click on the download button in order to get the latest version of the firmware. If you look at the module, you will see a micro:b USB port at the top. Please connect it to your PC using a USB cable. Once you have connected it, as previously mentioned, since the CircuitPython environment is already conveniently set up, you will be able to see a drive named CircuitPy. Additionally, it is important to note that if you open the bootout.txt file here, you will see that CircuitPython 5.3.0 is installed. You can see that it is up there, and when we looked earlier, the latest version was 7.3.2. Let's try updating this firmware. If you look on the left side of the module, you will see RST written, which indicates the reset button. Please double-click it quickly. Now the color has changed like this, and it has switched to bootloader mode. As you can see now, it was CircuitPython before, but now you can see that a drive named FTHR840 boot is recognized. Please simply copy the most recent firmware file that we downloaded earlier and paste it here. You can see that the connection is immediately lost as soon as the copying is done. After the connection is lost, the firmware is updated and then it reconnects, showing that the CircuitPy driver is reconnected. If you check the bootout.txt file here, you will see that CircuitPy has been updated to version 7.2.3. And in my case, I will be using Visual Studio Code, commonly known as VS Code, to work on this CircuitPython code. CircuitPython is a version of Python designed to run on microcontrollers. I will navigate to the path of the CircuitPython folder link in the terminal by using the cd command, and then I will proceed to run it in Visual Studio Code. Now I have opened the CircuitPython path in VS Code by opening the folder. This is an essential step to ensure that all necessary files are accessible for editing and execution. Next, if you look at the extension panel, you will find the CircuitPython extension by searching for CircuitPython. This extension is crucial as it provides tools and features specifically designed for CircuitPython development, enhancing your coding experience. I have installed the CircuitPython extension. Then, if you search for CircuitPython here, you will see Choose CircuitPython Board. Select NRF52840 and then choose Express. This selection is important as it determines the specific board configuration and capabilities you will be working with. After that, in CircuitPython, select the connected serial port by going to Select Serial Port. This step is vital for establishing a communication link between your computer and the CircuitPython device. Finally, you can check the output from the device in Python through serial communication, which allows you to monitor and debug the device's behavior in real time, ensuring that your code is functioning as expected. So if you open the serial monitor, you can see Hello World being printed from the device. After that, you can close the serial monitor. Let's quickly try blinking the LED and displaying Hello World. Here you can see the input, mode, and the commands related to controlling hardware are included here, such as followed by from digital, I/O, import the digital in out, library and set the pin, mode specifically for the direction. If you take a closer look at the digital in out mode, you will notice that there is a blue LED indicator. Currently, the module is configured with this module's LED direction set as an output, which causes it to blink at a regular interval of every second. From the time, input, and sleep functions, while passing through the loop, the value should be maintained at a high level through the loop, through the digital pin 1, and then proceed to the first grip. This setup ensures that the LED provides a visual indication of the module's operational status, making it easier to monitor and troubleshoot if necessary. In this particular section, you have the ability to effortlessly save any modifications or adjustments that you have made while working in this current state of the application. When you save it, you can actually see the blue LED, the basic LED, blinking as you see now. Then in this state, if you open Circuit Python and the Open Serial Monitor, you will see the LED turning off and on in sync with the off, on, off, on sequence. Here, similar to when using Arduino or ST, you set the LED pin in the pin configuration as digital in-out, then configure it as an output. Depending on whether you set the value to true or false, it determines whether it is high or low. Print and sleep are standard Python code, so I use this code to output to the terminal. This time, we built a CircuitPython environment using the NRF52840 kit from 01 Studio and ran a simple example. Next time I will explain other ways to control CircuitPython using this NRF52840 kit. Then I will see you next time.